Yeah, thank you everybody for coming. Yes, today we've got Almiray, who will be speaking remotely. I think he's based in Switzerland. I'll put him up onto the big screen in a second, but I just don't have my face on the screen. Be a bit frightening. But yeah, so thanks to Rental Cars for having us in this venue again. It's a great space. Thanks to Evolution for sponsoring us, as always. I think that's kind of pretty much it in terms of, I'll say a few things after the event about kind of what we've got coming up in the next few months. But yeah, I think I'll try and hand over to Andres without making a mess of this.
All right. How's everybody? Can you hear me? Yes, perfect. Well, first off, thank you for being here. And I know this is kind of unorthodox, the first remote transmission for your Java user group. So I'm quite happy that we can test this out. And hopefully, if this works correctly, then you guys can have other people joining in this way. So let's see. I'm going to share my screen. And let's begin with the presentation. There we go. Okay, so I'm gonna switch here. You didn't see anything. All right. So as you saw in the announcement for the session, actually, I think that you guys voted on the particular topic. So today we're gonna make it the Java libraries you can't afford to miss. And I know it's going to be a little bit strange given that I'm pretty far away from you, but in any moment, if you have any question, please let Alison and Nick and everybody else that is part of this the crew, let them know so that they can send the message through one of the chats. And I will try to answer them as quickly as possible because what's important about questions is the context. And let me remind you that there are no silly questions. There's always, if you have something in your mind, then please let me know as soon as you can. Okay, so let's get going. What I have for you today is the following use case. The libraries that we're going to see today, we will be seeing them in the context of a desktop application. Yet, you can also use them on the web, on the server side, even on mobile. Okay, and I also expect that some of you may be familiar with a few other libraries. Because again, these are perhaps what I consider the libraries to be the cream of the cream, the libraries that you can definitely must use as much as possible. So the use case is this one. We have an application that will consume a REST API. And we'd like to have components that are small and reusable so that we can create bigger applications if we follow the similar design. And because of the types of libraries and frameworks that we might use, it's most likely they're going to be based on POJOs or some other conventions, and it's very likely that we need to write a lot of boilerplate code. So it would be a good idea to find a way to not do this. And finally, it's very important that all our components or the code that we have is highly testable. Okay. So without any further ado, these are the libraries that we're going to see. I have split them into two camps, the production and the test. So those that have a vertical bar on them are the ones that you can switch for one another. So at a quick glance, you probably see some of the stuff that you already know. And hopefully, by the end of the session, you will be able to be interested in having a look at the other libraries. So a big disclaimer, once we get into this, is that everything that we're going to see today is open source. All the libraries are licensed under different OSI certified licenses. You can use them directly as is in your commercial offerings or any other kind of project. And as said, my goal for today is that you feel like this at the end of the session, and hopefully we'll get a try to one of these libraries. And so hopefully one of these libraries is near to you. Okay, so now let's get started. So my name is Andres Almiray. I'm from Mexico. I currently work for this company called Kenny in Switzerland, from where I'm currently streaming. And as I've been doing this for close to 20 years, I believe, so far. And during that time, I have collected many experiences working with different projects, open source and commercial. And this is where I gather all that information and come to you now with this distilled information on the libraries. I'm also a member of the Groovy development team. I love the Groovy, I love the Java. I'm a member of the Griffon development Griffon project, which is a framework that we can use to create desktop application in JavaFX. I don't expect too many people in the audience to still doing JavaFX, but in case that you have to do or work with desktop applications, then just give it a try. You might be surprised if you haven't seen it before. Okay, so remember what we're going to see, and I'm going to show right now the application, or at least one of the versions of the applications. So you guys should be seeing now a doc terminal. The code let's run the application right now. There should be a window on the screen. I'm sorry, this is a little bit small. The idea is that you type the name of a GitHub organization, and we collect the list of repositories that are associated with that organization. For example, I'm going to pick the Griffon Legacy organization, which I know has a good number of repositories. And this application for now is going to load only the first page. There are other versions of the same application, for example, version number 3. But if I run, this one is able to handle different pages, because the GitHub API allows you to query the different endpoints using pagination. So in this one, you will see the number here starts to grow and grow, go to 234. And we can give it a name for a different organization. You probably saw that the buttons change state. Some of the stuff that I can do, we can see that the UI is responsive because that thing was animated, blah, 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 blah. So this is what we want to do. It's quite basic. So how are we doing so far? Okay? I hope so. All right. So I chose to use the GitHub API because it's very well known, it's very well documented, and that's the URL where you can get it. And given that the GitHub API is quite big in the terms of capabilities that it offers, we're going to use only how we can query repositories. So what we want to do is, if you follow that URL, you see the description on what you have to do in terms of the input and what kind of formats and outputs you will get when you issue a request. Basically, what you want to do is issue a GET request like this one with that particular URL, the organization placeholder. You will substitute it with the name of the real organization, and you will end up with a huge JSON payload that may look like this one. So this is basically a list, or sorry, actually a JSON array of different JSON objects. Each JSON object describes a repository. And each repository has about 40 to 45 properties, if I'm not mistaken, and GitHub, of course, can add new properties at the leisure. And we only will be using a few of these properties. You will notice that the full name property follows the standard JavaScript naming convention, which is camel, snake case, and also HTML URL. But in Java, we prefer to use the camel case convention. So when we will have to map a JSON to Java, we have to do something about this. Okay. So what we need to build this application is, I would say, we start with dependency injection, because this time is 2017. It's somebody that builds an application without using dependency injection. You may be doing the work twice, and it's better if you start already with this. Of course, we need to issue HTTP calls and apply somehow of REST behavior on top of the calls. We definitely have to map JSON output to Java objects. We need a way to reduce the boilerplate code that some of these libraries or frameworks will impose on us. And we have to handle concurrency in some way. Because if you remember the old days of writing desktop applications, especially with Swing, everything that is UI-based must happen inside the event dispatch thread or the UI thread, whichever it may be. And everything that is not, for example, a network call or a database access or file access, has to happen outside of the UI thread. So our little application, even though it's small, we have to think about multiple threads. We have to think about concurrency. Okay, so you can get all the code. There are different variations of the application, as I said before, and all this code is open source. You can get it from that particular URL. And don't worry, you will get the slides at the end, so you can browse through all the different links that you'll find on the slides. I guess we also will have a recording. So let's start with dependency injection. I will expect that most will be familiar with some sort of dependency injection, so let's go quickly through this one. Basically, what we want to do is establish a contract on how a component may behave. Now, there are different ways to do this, but the way that we recommend is to follow an interface design approach when we design the contracts using interfaces such as this one. It's a simple interface that will let us know how to query a repository, and we give it the name of the organization, and we get as a result something. We will see that something in just a moment that returns a collection of repository objects. Now, what we want to do is to make use of that component somehow. Let's say we have a controller. The application that I show, you follow the MVZ pattern, which means that there has to be a controller, there has to be a model, and there has to be a view somewhere. So the control is quite simple. And you see it right here in all its glory. This is the first iteration, where what we want to do is inject a model and a GitHub object that will give us the capabilities to query the repositories. And what we do with those repositories, we'll see in just a moment. So the way that we can use dependency injection, the easiest way is if you follow Guice. If you use Guice from Google, it's a very well thought project, if I would say so. It doesn't have any memory leaks, and it only does one thing and one thing only, which is dependency injection. You can create the definitions of the types that you want to resolve using the Java-based API. And here I'm showing 3 examples. The first one is how you bind a source class, which is GitHub, to a target class, the GitHub info, into a specific scope, singleton. But you can have different scopes. So if you're on the web, you may have a conversation scope or session scope or even application scope. And you can create your own scopes. The second type of binding, this is both the source and the target class. There are no the other implementations of the same class, so you can use it this way. And the third example is how you create lazily a new instance. We use this thing called providers. And if you know Spring, you might have seen them with a different name. They are called factory beans, but it's basically the same thing. The GitHub API provider class will create something that implements the GitHub API, but just at the moment that we actually need it. In this case, these singletons, I believe, will be instantiated eagerly. So those instances will be ready whenever someone wants to, needs to consume them. There are 2 other more versions of bindings, but this is pretty much it. The reason why I like to go with Guice at the first time is that if the only thing that you need is dependency injection, then this is the best thing. And secondly, Guice is the reference implementation for JSR 330, which is the JSR that defines how dependency injection should be done in the Java platform. You can bind pretty much every type of types. You can bind instances. You can even bind constant values. And this is one of the features that I use in the source code. So when you have time to browse through the source code, you will see how I make use of one of the constant values for testing. You can also provide lazily evaluated instances using providers, and it has an extensible lifecycle. So you can listen when a type is defined, when a type is instantiated, when an instance is provided, and a few other things. And there, you might have seen in other dependency injection containers that they also honor a few other annotations, such as pause, construct, and pre-destroy. Well, Guice doesn't. But there is an extension to Guice that allows you to have that capability. And the extension is also configured in the source code because there will be a moment where we actually need to have something reacting to the pause construct event. If you happen to use Guice, then you get a bonus library, which is Guava. Google Guava was created quite a good number of years ago. I think that's close to 8 or 9 years ago. And it was created as a response of the JDK not having enough utility classes for dealing with collections and also dealing with functional constructs. I'm hoping that most of you have already switched to JDK 8. If you haven't, just be aware that JDK 9 might come out next month. That's what we have been promised. So you still have some time to update, and trust me, JDK 8 is pretty good. So if you're in JDK 8, you know you can have some functional constructs with streams and lambdas and optional. But if you are still in JDK 7 or 6, then Guava will give you similar constructs. The API are also almost the same, but when you migrate from one to another, just be aware that some things might change. Also, the behavior is almost the same. So be very careful, but Google Guava is quite good. If you don't use Juice, then it's very likely that you have encountered Spring. And here I just want to talk about the Spring Core framework because Spring has a huge portfolio of projects. So the Spring Core framework gives you dependency injection, but it also gives you a few more things. Of course, it also implements JSR 330, so it supports all the annotations provided by this standard, but it gives you other capabilities such as better testing, assertions, creating JMX clients or servers in a very, very easy and understandable way. It has support for validation and scheduling and JDBC. And I don't know if you know, but the message formats, the default ones coming from the JDK are not thread safe. Those of you that have seen the simple date format, you might have encountered in the wild some problems with this particular class because, well, it's not thread safe. So what the Spring Core gives us is some additional message formats that actually are implemented in such a way that they are thread safe. So that's one of the few things that you can have just by the nature of using a Spring Core, the freebies that you get. Okay, so moving on. The next one is reducing the boilerplate code. And most of us are familiar with the Java Beans conventions, which means that if you want to have a property, then we have to define a property field and a getter and a setter following this naming convention. And if it's a well-behaved POJO, then you may want to have your own custom implementation of the equals and hashcode method. You probably want to have also your own custom version of toString. And if you have hierarchies of objects, then you have to consider if you want to call the equals and hashcode of the superclass or toString, whatnot. So things, it sounds easy, but when you have a rich domain and a rich hierarchy of objects, then things start to get complicated. I'm aware that all major IDEs allow you to generate source code. You can start typing in a private field and then do generate getters and setters, and boom, you're done. You can also generate a constructor. And you can rename those things as well. That's easy. But we start to get in trouble when we need to delete one of those properties because there is no easy refactor to delete those. Another thing is that machine-generated source code gets out of date immediately after it gets generated. And now you, the developer, is the one that is in charge, and you are now have to own those the sources that have been generated. So I would say that, and well, in my case, I would prefer if the compiler will be aware of these conventions and probably make the compiler be aware of different conventions that make sense for your particular project. Sadly, in Java, we don't have an API that will allow us to do this, something like macros or ST transformations. But what we have is Project Lombok. Project Lombok hooks into the compiler process using the annotation processing tool. And what we have here is the POJO class that represents the repository. Do you remember that JSON payload that I showed you before that has more than 40 properties? Well, here is everything that we need just to map 4 of those properties. Using 2 projects, as a matter of fact, here. We're using Lombok and we're using Jackson. Lombok will allow us to reduce the amount of boilerplate code, and Jackson is the one that allows you to map a JSON to Java. So we have 4 properties: name, description, full name, HTML URL. You'll see that we use the camel case convention, which is what we like to do in Java. But we also use this add setter annotation from Lombok with something that looks quite ugly. I must say that it definitely looks strange. But what this setter method is going to do is generate a setter method for that property. And it will add the add.json property annotation to the setter method as if we wrote it ourselves.
We also annotate the class with another annotation called JSON ignore properties, ignore unknown true. This means that we are only interested in 4 properties. If there are any other properties that are not mapped by fields in this class, then Jackson will simply ignore them. If you set this to false or do not set it, then if when the 5th or the 6th property comes in during the serialization process and Jackson doesn't find it, they will get a runtime exception. So this will allow you to evolve a JSON-based API, because you can react to new properties being added, or you can simply say, I don't care if there are new properties, I just only expect these 4 or 10 properties, and if you add more, that's okay. My code will continue to work. So it's up to you to decide what's going on. And finally, the add data annotation. This is the secret sauce. This will generate getters and setters for all fields. If you happen to define one of these fields as final, then it will only generate a getter and no setter for it. It will generate equals and hashcode methods that follow the conventions and the rules specified by Josh Block in Effective Java, I think the 2nd edition. It will also generate a toString method. You can give it hints if you want to call the superclass definitions of those methods, if there happen to be one. And it will also generate a constructor for you, especially for those final fields. If you happen to also annotate any of these fields using the @non-null annotation from JSR 305, or the not null annotation from Lombok, or the non-null annotation from Spring or IntelliJ, then guess what? Lombok will understand that and will add enough code so then when you happen to call the setter with a null value or a constructor with a null value, it will give you a much more detailed message instead of just saying, null pointer exception, I don't know what happened on line X. So the next thing is sometimes we want to have immutable classes, but we need a way to construct them. And the builder pattern is something that most people like to use. But creating a builder class is also a lot of boilerplate code, because it follows a convention and it's a little bit of repeated code. But guess what? There is a way to create builders very easily. Just apply the builder annotation on a static method. You can give it any name. And based on the arguments of those methods, those are the property values, if you will, that you will get. So internally, you can create the object, using the constructor or some other means, and the return object might be immutable, but the builder, of course, is immutable. If you happen to apply the @non-null annotation or @nullable on these ones, then you also get those additional validations that I was telling you about before. You can change the name of the generated class or the generated method with additional properties or attributes that you can set on the builder annotation. Otherwise, you can use the defaults. And this will be enough. So now you will have a builder class related to the repository object. Here's another example showcasing that you can have, this right now is just 2 classes in a hierarchy, but the subclass can be a well-behaved project where the superclass is just a simple or empty class like we're seeing, an application event, and yet you can still have the full power of Lombok. In this case, the new instance event will have a constructor that takes a single argument, and because it's annotated with unknown null, it will have that validation. So we have a proper message telling you that the expected instance field to be non-null, but something happened. So I really like to use Lombok, but I had to put it out in the open. Lombok is one of those projects that will polarize people. You either love it or you hate it. There's nothing in between. Because Lombok does something that scares people, and that is manipulate the bytecode as it goes. Not only can it generate new classes on the fly, but it can also change the bytecode of the class that is annotated. That's exactly how it generates getters and setters for a particular class annotated with that data. So some people will consider this to be a dangerous feature, and some other people will be fine with this. Regardless of this, you have to be aware that you must use the annotation processing tool. So if you're running Lombok on your IDE, you must turn on the annotation processing feature. If you're using NetBeans, this turned on default. There's nothing that you need to do. If you're using IntelliJ, there is one checkbox that you have to tick in the preferences, and the processors can be grabbed from the class path. If you're using Eclipse, then let me tell you that you need more steps to set this up. Not only do you need to set it up per project, but you also need to manually locate all the processor jars. So it's a bit of a pain, but you can still make it happen. Now, most of the annotations or the conventions that you like to use are already provided by Lombok, so you don't need to write a transformation by yourself. But if you do, it is not for the faint of heart. It's a little bit difficult because you have to know the target compiler, whether it is Java-C or the Eclipse compiler. But if you're able to make it happen, then you'll be rewarded by writing less source code and make the compiler be aware of your own conventions. I would recommend that if you follow Lombok and you want to use Lombok, just apply the data, setter. You can also have getter and builder annotations, those that deal with creating POJOs and builders, because there are others for you to create to actually transform check exception into a runtime. It's called a sneaky throws, and some other things that I really don't want to mention. I know they're there, but think for a moment they do not exist. Only work with those that have to deal with POJOs, and you should be fine. You should be safe. The next one is when we get into the behavior proper of the application. So when we're developing the application, or actually when it's already launched into production, we would like to know what's going on, if there's something that we need to be aware of. And the quickest and the easiest way that we as developers do, at least this is what I used to do for a long time, was to just go with printouts. But using printouts is quite bad. So the next thing that we can do is use a logging framework. Now, there are a handful of logging frameworks out there, but sadly, none of them are really good. That's the sad reality. But of those of there that are out there, I would say that SLF4J is the best of them because of two features. One is that it allows you to concentrate different logging frameworks into the same API. Because say, for example, that you're consuming a Red Hat-based or JBoss-based dependency. It's very likely that it uses JBoss login as a dependency for login. Or if you use a Spring, it will use SLF4J, or use some other Apache-based library, it's most probably going to use Apache Commons login. And if this is the case in your big application, you will have to configure login in different ways. But with SLF4J, everything goes into one single place, and there's only one set of appenders and just one binding for login that you need to configure. That's a great thing. The next one is when we're using our login statements. We have to be aware if the login level that we are, what I would like to call, is enabled or not. Because otherwise, we might spend a few CPU cycles creating a message that is going to be discarded because the level is disabled. So what we do is start adding if guards to our login statements. But our code looks much uglier than before. So if we were to use variable arguments, a really nice feature available in Java for a long time, then the login statement becomes much simpler. You simply pass a string that looks like a template and a series of values that are going to be substituted when the time is right. So if the level is enabled, and this is what the login method will do inside, it will check if the level is enabled. If it is, then it creates the final message and goes directly into the login appendix. If it's not enabled, then it's simply discarded. So you didn't lose anything. You didn't spend too much time, too much CPU cycles logging, and you didn't clutter your source with a lot of guard statements that were not needed. You can also use log4j2, which gives you the same benefits, the same API. What's the difference? That SLF4J has had more time in the market, if you will. So that means that there are many other libraries out there that use it. It may be the case in the next couple of years that log4j2 becomes the most popular framework. So it gives you, again, pretty much the same benefits. The next thing is, how do we get into HTTP? And I would expect that most of you are familiar with Apache HTTP Commons or Apache HTTP Components or Apache HTTP Client. They have changed the name across the years, but it's pretty much the same set of APIs. And on top of HTTP, we had to build REST capabilities, because if we just deal with basic headers and responses and requests, that is very low level. We want to go to the next level, which is issue something that understands a GETful API or a RESTful API. As I mentioned, there's of course HTTP client, but I would like to showcase now something called OkHttp, which is a much newer HTTP-based client. It is built by the Square company. They target Android environments, so the libraries that they build there are quite small in memory footprint. They have little to no dependencies, but they also work on the big scale, such as desktop on the server side. So what we're seeing here is a very basic example of an HTTP client. Once you create a client, you create objects of type request, when you can configure the URL if you want to make it up a get, call, or post, or some other HTTP method. You can pass in headers. You can pass in pretty much, you can configure anything you want to from HTTP. Then you issue the call, and you get a response. On the response, you can inspect the headers. You can inspect the status of the response. In this case, I'm not doing it. I'm just doing willy-nilly. If it's successful or not, I'm simply grabbing the body and put everything in the string. If this happens to be a 500 call from the response from the server, then, well, the response will be how it looks like. Now, another advantage of using OkHttp is that it is HTTP2 ready, which unfortunately for Apache client, it is not. So if you already have a server API that must run on HTTP2, you need to have a client, then OkHttp will do it for you. Here's my reasons to go with OkHttp. It gives you HTTP 1.1.1 and it's HTTP2 ready. It's extensible via factories, and we'll see that in just a moment. And the HTTP lifecycle can be decorated via interceptor, so that's how you can add behavior for handling basic authentication or OAuth or any other kind of authorization authentication. And if you want to spoof or sniff the headers, then just add another interceptor, and that's it. For whatever reasons you need to do this. Okay, the next is how do we add our behavior on top of HTTP and REST? Because it's okay that we can issue network calls, but we are Java developers. We deal with Java types and domain objects and collections of these things. We don't have to, or we shouldn't be dealing with low-level stuff at HTTP. There's another thing is that regardless of how we do these things, we need to investigate, we need to see what are the responses, what are the headers, what are the status messages, how we deal with connection errors, how we parse from format X or Y, whether it's XML or JSON, YAML or something else into Java objects. And these are tasks that can be performed by somebody else. We as developers, we don't have to do this every single time for our application. And here, the library that I want to showcase is called Retrofit, also from the same company as before, Square. What they propose is the following thing. You define an interface that contains the contract of the API that you want to consume. In the case of the repositories API, we have two different entry points. One that we showed before, which is the get with a certain parameter. And the other is the next page. So if you happen to have pagination in your repository, in the reply, then there will be pagination links in the headers in a specific name. This is what the GitHub API can tell you in the documentation. And once you find that URL, then you can follow it using the second link. So we will enable clients, in this case, like controller, that will be our client, to follow these next URLs, and just by doing this. The next thing we're going to do is create the actual HTTP object that will issue the calls, but it will do so by making use of this API that we just defined. So here it is. It's called the retrofit object, so we created it using a builder. we set up with a certain API or URL, in this case, the API github.com, this is the real deal. And we add a factory. This factory understands how to do the mapping within JSON objects to Java using Jackson, what the library that we previously saw. And that's it. Once we have this retrofit object, we can create as many clients that we want. So for example, here's one way. We create retrofit client, passing this GitHub API interface, which is the one that we defined in the slide before. So what this call is doing is basically creating a Java Lang Reflect proxy on top of this interface, the GitHub API class. And internally, that proxy implements all the methods using HTTP because of the stuff that we pass here in the builder. Now, the object that gets returned here will be the one that we see in the last line, which is this GitHub API implementation. And we can simply call repository, which is the Java method that we define, passing a simple string. And the output of this will be a collection of repository objects. Everything else that is HTTP will happen under the covers, and we don't have to deal with the complexities. The great thing about retrofit is that it allows you to REST calls using Java interfaces. It's extensible via factories, and it uses OkHttp as the underlying HTTP client. So again, HTTP2 ready, and it's quite fast, it's quite good. How are we doing so far? Any questions in the audience? You just let me know. We are almost finished with production, but there are two more things that we need to deal with. One of them is, of course, multi-threaded code. And let me remind you again of the golden rule of UI development in Java, at least on the desktop, which is anything that is UI related has to happen in a specific thread. So when you read or you write properties on a widget, or you paint, has to be inside the UI thread. And anything that is not UI will have to happen in a different thread. It doesn't matter which thread it is. It may be a background thread that you create or something that is scheduled on an executor service. As long as it's not the UI thread, then we should be fine. So in the Java space, I know I said I jumped very quickly to give you the answer. But in the Java space, we have seen a few attempts to make this happen. But if we take a hint from the JavaScript communities, they have something called promises. Basically, a promise is an asynchronous object that will, at some point in time, that's what we have, that's why it's called a promise, will have the value that we expect. And when it has it, it will notify us using a series of callbacks. If it doesn't have it or it encounters an error, then it will also notify us using a different callback. And it will be great that whether, regardless of the obtaining the value or the background task was successful or it will encounter an error, then we also get a different kind of notification. So what we have in Java is called JDefer. JDefer is inspired by jQuery promises. So it has an API that is very, very close alike to promises, but of course implemented in Java. Then this is the type that we saw earlier, it's called the promise. And the generic placeholders that I have will give you three capabilities. The first one is the return type of the promise. In this case, will be collection of repository objects. The second type is the type of objects that will be returned as an error. It may be a throwable, but it could be anything else. It could be a string if you wanted, or another POJO if it makes sense for your domain. And the third type is if the task that you're running in the background happens to compute intermediate results and you want the consumer to be notified of these intermediate results as soon as they happen, then you will use this thing. You might remember we have these capabilities in Swing Worker from JDK 6, because it's basically the same thing. So now we have to see how we produce the promise, and then we will see how we consume the promise. So producing the promise is quite simple. There's this object called Defer Manager, which is an abstraction on top of an executor service. So you can configure many things, many aspects on this object. But the main gist is this one that we'll see the implementation of the method is invoking the when method, and we pass a lambda. Well, you could pass anonymous inner class using JDK 7. And this lambda here, these three lines of code, that will be the background task. We know we are guaranteed by the thread manager that this will happen on a different thread, on a background thread. And here we make use of the retrofit client that we saw earlier. We know for a fact that will be a network call, so that's had to happen on a background thread. We get a response object. On the response, we can ask if it's successful, and if it is, we simply return the body of the response, and that automatically will instruct retrofit to translate the JSON objects into Java objects and put them into our list and a collection. That's what we're expecting, and there we go. There's nothing else to be done. If the response is not successful, then we simply throw a new exception and say, well, something happened. Another thing that you may be thinking is, what if there is a network issue? What if the network goes down, or there is a timeout or something else? Well, it's most likely that an IO exception will happen. Well, the implementation of the when method, the thread manager, will catch any exceptions and will mark the promise as rejected automatically for us. So we don't have to do, we don't have to keep this. We don't even have to cache these exceptions. We don't have to do this bookkeeping for us or house cleaning. The thread manager will do that for us automatically. So that's how we create the promise. Let's see how we consume the promise. Here's a variation of the promise that returns a collection of repositories, throws a throwable in case that there is an exception, and this variation also pushes intermediate results whenever it encounters a repository. When we invoke the promise, we can have 3 different callbacks. The first one is whenever there is a new notification that there's an intermediate result, a new repository, we're going to add it to a list of repositories using method reference, because why not? You could use lambdas if you want to. If there is a failure, then we simply print out to the stack trace. A real application actually does something else with this. We'll see that also in a moment. And whether it was successful or not, we will always would like to change this state, because this state is how we control how the bottom gets enabled or disabled, because you might see at the top of the code, we change the state to running, and eventually, success or error, we change the state to ready again. So we are guaranteed by the promise, unless something really terrible goes wrong with the JVM, not with the promise itself, we are guaranteed that this will happen if it's a success or error, whenever we terminate successfully. So that's pretty much it. JDefer gives you those capabilities. I really like this library. You can chain promises. You can transform values from one to another. It's Java EF friendly, as you saw. You can use lambda expressions or method references. But it's useful for a one-shot execution. That means that you have a task that can calculate a value and then you're done. But there are other applications where we would like to have a series of values, or more exactly, a stream of values. And this stream will be maybe created at any point in time, and the values will come at any point in time, and you just want to consume them as soon as they happen. Well, JDefer and promises will not give you that. But there is another thing that we can use, and that is called reactive programming. There are many ways to do reactive programming in Java. It's probably the most well-known project out there is called RxJava. And RxJava, I think I made this slide with RxJava 1 in mind, because if I were to use RxJava 2 instead of an observable, that would be a flowable object. What is the difference? Flowable is aware of back pressure, whereas observable kind of does, but it doesn't handle back pressure correctly. So if you're already switching to RxJava, make sure that you use flowable. So say somehow we are able to create that observable, and we start decorating the observable with new operations, and that's exactly what we're going to hear. This is the important thing that we couldn't do with JDefer before. We're going to give it a timeout. Because if querying the network takes more than 10 seconds, at least that's our expectation, then we expect this thing to fail immediately. We also, when we subscribe, that is when we start listening to events, we change the state. And when we terminate, again, regardless of success or error, we also change the state. So it's quite symmetric in this case. We also subscribe on a background thread. This is what the scheduler's IO is giving us, so that we know that this task or listening to these values will happen on a task, on a thread that is not the current one. And when we subscribe, we can do 2 things. One, whenever there is a new object coming on from the server, a new event, we add it to the list. And if there happens to be an error, we simply print out to the stack trace, we put to the system error right now, but there will be a way to handle this. It's possible to use retrofit and RxJava together. The first thing that you have to do is update the contract. You remember that you might remember this used to be just call or restore repositories, and now it's an observable or responses. This is a type from a retrofit. And observable is a type from RxJava. And the rest of the API stays the same arguments and the same annotations. The next thing you do is that you make sure that the retrofit builder or the retrofit client is aware of RxJava. So you only need to add one more line, which is the RxJava called after factory. So with this now, whenever you invoke your client, it will create an observable object that contains a response that contains all the contents that you want for that particular HTTP call. Given that we want to paginate or handle different pages, then we have to follow two different methods in our API. One, to query using a simple name, a parameter. This is the simple get. And the second one that understands the URL. Now, the GitHub API documentation states that there will be a links in header, in the response header, and what will be the format of those links. So there will be a next page or previous page, last page, or first page. So this object here, links, with something that is also found in the source code in the repository, understands how to pass the headers, and will let me know if there happens to be a new link or not. So this is the first step. And this method that you see right here on the top, paginated observable, is something that we're going to use to somehow combine observables from different pages. Because every page that we invoke will result in an observable or response of list of repositories. So we have a list per page. But if you remember the controller, let me show it again here, we have simply observable or repository. So all the lists have been combined into a single stream of observables. It's a great thing that RxJava gives us the capabilities. It has many operations that we can use to combine these things. And here is. We pretty much, what we do is flat map. So at the bottom of the page, flat map on the responses. Once we get our response, and if it's, I guess this is successful every time. Yeah, we grab the links. And this is the list of the current page. And if you happen to have links, then we simply concatenate the current observable with the responses of processing the page with the next one. So we are calling recursively ourselves until we get all the different pages. And what's nice about concat and flatmap is that even though we started with a list of T, we end up with just an observable of T. That will be our repository. And boom, that's easy as that. Reactive programming requires you to do a paradigm shift on how we reason about operations, because we have to take into account the time. It is not the same as when we do in imperative programming. We expect values to be assignable immediately, whereas with reactive programming, because everything is asynchronous, then values and operations will happen across time. RxJava, I think might be the first implementation of where the reactive extensions in Java is perhaps the most popular project, but it's not the only one. You can also use Project Reactor from Pivotal. Both of them have almost the same API, so you can switch from one another, minus a few source changes. Both of them support also the concept of back pressure, which means that if the producer is creating a lot of events and the consumer is too slow, is being bogged down, then the consumer can tell the producer to wait up, or the consumer can buffer the events. And once it has finished consuming the current ones, then it can go into the next batch. This is something that we were not able to do with RxJava 1. And there are plenty of operations that you can apply on the observables or the flowables. So there's hardly any need for you to create your own custom operations. You simply compose on the existing ones. Finally, At some point in time, we would like to have our components to be aware of one another, but in such a way that you want to send a message from one component and let another component be aware of that message. So yes, we have dependency injection, which means that you can have a direct reference from one another. But it would be better if we can simply say, hey, here's a message, here's an error, something happened, and I'm not a UI component, in this case it's the controller, and says, here's an error. Somebody handle that, please, and I'll continue doing whatever I want. And that other component that will listen to that event will be an UI-based component. So what we can do for this is apply or use an event bus. If you use Guava, there is a basic event bus in Guava, but I would say that MBassador provides a much better API. So what we're seeing here is how we can publish an event. You look at this code looks a lot like what we saw before in the RX Java code. What looks different is the third line from last, which is how we handle the errors. We know for a fact there's going to be a trouble coming down the stream. So what we do is now remember that trouble event class that we saw earlier with Lombok. Well, here is, and there's a constructor created by Lombok. And we simply tell the event bus, publish an event in a synchronous manner, which means the emitter will say, here's an event, and they'll continue doing whatever job it needs to do. Whereas it will simply say publish, it will wait for all the consumers to finish handling that event. So sometimes you want to do that, that's a blocking operation. Or if you do async, it's pretty much a fire and forget, and then you let the other components do and continue the job that they were currently doing. How do we consume the event? That will be the next slide. As you can see here, the class can be any type. We have to register ourselves with the event bus in order to start listening. So this is the reason why I use post construct and predestroy. So when this particular type, the application event handler, is instantiated by the dependency injection container, it will get the event bus as a dependency and will subscribe to it immediately. And when the dependency injection container decides that it no longer requires the instance, then it will call the predestroy event. And then this particular instance will unsubscribe itself from the event bus so that we don't leak any memory. That's pretty good. And the last thing is how we handle the event. And for that, we can use any method name. It can have any visibility modifier. I decided to go with public, but it could even be private. It has to comply with two rules. One, it has to have the @handler annotation from MBassador. And secondly, the type of the argument is how it can match the particular event. Inside, once you get the event, then you can do whatever you need to do here. If you see the code in the repository, there is a handler that takes the error and generates a dialog and presents that dialog using JavaFX. And that handler is UI related. Whereas if you go back to the controller, this producer or event emitter has no idea about UI. It simply says, here's an error, I wrap it in an event, somebody handle it, and continue to do whatever I need to do. That's what I like about lightweight event buses. MBassador is quite good. I really like the API. It's friendly with dependency injection. It's much better than Guava. There is a benchmark showcasing why MBassador is much faster. Yet, the author of the library is not very much active as it was before. So if you were to encounter a problem, then the reply might be as slower as expected. This being said, we have in production with a couple of our customers, we have MBassador running, and we haven't encountered any problems whatsoever. So it's quite good, it's quite stable. But I felt I needed to mention that what is the current state of the project. So just you know. That pretty much finishes what we would like to cover for production. And now we get into testing. So before I actually jump into testing, is there any question regarding the libraries that we saw? I'm going to switch into Okay, so I'm looking at you guys, and if I don't see any hands, then I will continue with testing. Hey, Nick. Nothing. Okay, good. So let's go with testing. And let's go back. Yeah. Now I will assume. Actually, I wanna see this. I'm gonna poll the audience right now. So I would assume that most of you use JUnit in some form. JUnit 4. Has anybody already tested JUnit 5? Not yet. Okay. TestNG. Any TestNG fans in the audience? No. Okay. Spock. I know for a fact there has to be one. Yes, exactly. Excellent. Okay. My people. All right. So for those of you that use JUnit 4, you might have encountered the time when you need to parameterize a test case. And JUnit 4 gives you those capabilities. Sadly, they are a little bit restricted. What do I mean by this? You can certainly parameterize a test case, and say, for example, you choose a method that takes 3 arguments. And let's say the first argument is a string, the second argument is an integer, and the third argument is a list. You can do this without any problems with JUnit 4 parameterization. But based on the kind of a scenario that you have, the use cases, you want to have a second method for parameterization in the same test case. And this method will use a different number of arguments or different types. Well, guess what? JUnit 4 will not help you here. What you will end up doing is creating a different test case. And, well, now you have more files. It would be better if those scenarios, those use cases were to stay in the same file. So for that, yeah, I'm showing the slides. Here we go. For that, I would suggest to use JUnit params. So JUnit params gives you back those capabilities to parameterize any kind of method with any number of arguments, with any different types. And you can have as many parameterizable methods in the same test case. 2 things. First, you have to run with a specific runner. So if you already have another test case that has a custom runner, then you cannot use JUnit params. There's no way that we can combine different runners into a single unit. But if you do, if you're able to use the JUnit params runner, then you can apply the add parameters annotation on a method. You can supply the values directly on the annotation, or you can supply the name of a method that it's the data provider, or you can even supply the class name, or actually the class literal of a class that also functions as the data provider. Also notice that the method names, the method takes arguments, and I think that JUnit params is able to do simple type conversion. So if you expect a Boolean or an integer or any of the proper types, even though you define them as strings, then you will get them as with the right type. And that's basically it. I mean, JUnit params is just an easier way to do parameterization. Now, the next one. Mockito. Mockito is perhaps the best library that we can find out there to do mocking, because we're using dependency injection. Eventually, we need to test our class on the test in isolation. That means that any dependencies, any collaborators that it may require have to be lightweight. So we'll use a mocking for this. Mockito can be seen or can be thought as a DSL for mocking. I'm also using JUnit params for this particular test. So you can see that we also have arguments on the method. And the service class here is the one that we're going to mock out. And we set it directly in the controller. You can keep a reference to the mock. The mock method is statically imported from Mockito. We also have the when method, also is statically imported. And here this is how we define our expectation. On this, sorry, what I'm doing is wrong. I click on the wrong thing. On this proxy, which is the controller get service proxy, we invoke the method say hello with certain input. And if that matches, then we're going to return with certain output. Then in the next block, we execute the stimuli of the controller. So this is where we expect the mock to do its job. And in the then block, we validate that the controller do the right thing, but also validate that the mock did the right thing. This the verify method, also a static method coming from the static DSL from Mockito. There is a difference within the different objects that you can mock out with Mockito. You have 3 types: stubs, mocks, and spies. What we have here, even though the method name is mock, is actually this is a stub. We expect an interaction like this: controller gets service hello input, and then we simply say output whenever that happens. A mock is a much stricter version of a stub. Not only it has to match the exact invocation, but it also has to match in the same order and with the same cardinality. So if I were to have different invocation, different expectations, and if I were to invoke them in different order or with different cardinality, whenever I do the verifier at the end of the method, then it will tell me 2 few invocations or 2 more, or the order was completely wrong. And finally, there will be times where you have access to the real production class. Say, for example, I want to have access to the real service, but there's one method or 2 methods where I need to fake out. This is typically when we want to test out a code path that throws an exception that is kind of hard to get unless you do a lot of complicated setup. But if you do a mock, then that will be easy. But you want to also have part of the real production class. So that is exactly what the spy, which is the 3rd type of objects that we can mock out with Mockito, this will give you. What you're pretty much saying is that you're injecting code, if you will, at runtime on a particular method, and that will be the reply that you're expecting, and where everything else is just the real deal. Mockito is perhaps the project that is the fastest out there that is released. They make releases every single week. They make releases for every new feature or bug they fix. So you have to keep up with the pace. It is pretty much a fluid DSL for defining expectations. It can mock interfaces, abstract classes, concrete classes, and it can even mock out final classes. There are really, really just legacy cases where you would like to do this, but know that you can even do this. Now, I asked you about JUnit, and I think the next one would be, yes, Mockito. Yes, I was jumping ahead of the slides. If you're using JUnit and you're already using Mockito and you happen to use Google Juice in your classes and your application, then you can use Mockito, which is a combination of the 3 projects in just one place. It also comes with some runner, the Mockito runner. And notice that we can do injections on our test case. And what is great about this is that look at the definition of the before method. It takes an argument, which is sample service, and we didn't provide a binding for this sample service. So automatically, what Mockito will do is create a mock for us, and whoever requires the same type of sample service, for example, our sample controller, as we saw earlier, then it will get injected the mock automatically for us. We don't have to do it. And in this particular method, we're doing the same kind of expectation because we cannot use JUnit params again, because we cannot combine different runners. Then we are setting directly the values of our expectations right there, the input and output. And then the actual invocation of the stimuli, the say hello action, it just works because we got the injection of the controller, the injection of the sample service mock. We do the stimuli, then we do the assertions, and we do the verify on the mock. And that's pretty much it. It's exactly the same as before, but the advantage is that if there were 2 different places, or at least 2 places where we need to have the same mock injected, then Mockito will do the right thing for us. It's not exactly, again, using genuine params. It's something that's custom to Mockito. The documentation will tell you more about how you can do this. And you can also bind multiple values to the same source type. It's another way that you can parameterize the test methods, if you will. OK. So I asked you that if you use a Spark, and so you responded, reply saying yes. But well, here it is in all its glory. Spark is pretty much a testing DSL written in Groovy. And this is the test case that we saw earlier, but now written in using Groovy and a Spark. And this one is also parameterized. Now, those of you that have seen Groovy before know that you can do interesting things with the syntax. But those of you that haven't, take a look at the name of the test method. It's not the fact that the return type is def. That's pretty much object. That's the dynamic type for Groovy. Coming up in Java 10, that will be bar most likely, or val. We'll see what's going to happen. But look at the name of the method. What is that? That is a string. It contains spaces. It contains a sharp or a hash sign. I mean, I have found that this particular symbol has different names whenever you go in the world. So I'm going to go with hash right now. And that looks kind of interesting. What's going to happen is that this method is parameterized. So when the actual test method gets generated, these placeholders, so the hash input and hash output, will be substituted with the actual values for each invocation. So that will allow us to have much better descriptions in the test methods. Then the next thing is that we see for blocks, given, when, then, where. In the Spark, these blocks have a special meaning. In the given block, or the setup block, because those things are aliases, is where we create the class on the test, when we set up the collaborators, when we define expectations for our mocks. So that's exactly what we're saying here. The controller, the model, the service. There is custom support for mocking in a Spark. It's inspired by Mockito, but we use Groovy syntax. So what we have here in the body of the mock, that's a closure of a lambda, if you will. And inside that expression, we see the invocation of the say hello method and something weird, that operator, which is the left shift operators, how we are saying, whenever that input or that invocation, which is on the left side, occurs on that mock, then we're going to reply with that particular answer, which is the value of the output variable. And you can define as many things as you want, and you can also define different cardinality, if you will. Then on the when block is when we set this, when we invoke the stimuli. If you haven't seen Groovy before, controller.model.input looks like field access, but it's not. That's property access. If you inspect the bytecode, that will actually be controller get model. And then that assignment transforms input into set input. So that becomes controller get model, set input, and the value. Then we invoke that thing. And then we go into the then block. This is the implicit assertions block. This is when we expect all our Boolean operations to succeed. So that's why we don't need assert equals or assert, because this is implicit. And we kind of know that output is a string, isn't it? So controller.model.output, that returns controller get model get output, which is also a string. And we're using the equals operator. Is that the right thing to do? Is that how we compare strings in Java? No, it's not. But we wish we could. Well, guess what? Groovy gives you that capability because it has operator overloading. So the equals method gets actually translated into a call into the equals method. So it does the right thing for us. And the last thing is one of the ways, the last block is the where block, is that's one of the ways that we can parameterize a test case. So we're supplying values now. We're using the right shift operator, using collection literals. That's just a list of strings. And we push values into input and output. And given that we have two values for each, there's going to be two invocations for the whole test case. So it's pretty exactly the same parameterization as we have in the previous way. So the reasons to use a Spark is because of the brevity of the Groovy language. You can write less code and be more expressive. Groovy has the best interoperability with Java. Every Java class is a valid Groovy class and vice versa. There are no special bridges for you to call Groovy code into Java code and vice versa. So it makes it very easy to use Groovy and Spark for testing even a full-fledged Java production code base. You can parameterize multiple methods. You can parameterize method names. It's JUnit friendly, so you can consume any JUnit extension. And it also comes with its own mocking solution. So it has all the benefits that we saw from all the previous libraries, except for dependency injection. That doesn't do yet. I'm not aware if there is an extension to it, but I think that using Juice, there's another project called Juiceberry, which gives you the capabilities of doing injections on any kind of test case. There were two more things that we need to test out. Remember that we're doing concurrency, right? And when we're testing concurrency and background test, we need to wait out for some results. What is the quickest way that we as developers go with testing this? Thread.sleep, isn't it? Or now you can call the sleep method on a time unit, but you still have to handle the interrupted exception. The problem with this is that it will sleep for, let's say, 5 seconds. It might be enough for the test case to succeed, but we might be waiting too much. What if it's only needed 2 seconds or somewhere in between? It would be better if we have some way of conditionally waiting and not waiting too much. Otherwise, all of our test case will resolve very slow. So for that, there is this project called awaitility. Awaitility is another DSL that you can use to specify conditions so the test case can wait. So now we know, so this is kind of an integration test. We know that invoking repositories here, this method, will run on a background thread. Actually, no, hold on a second. Invoking the controller.load method, we know this is going to happen in a background thread because of the concept of this, we're using observables, right? Okay, so we know that up to here, controller.load, everything was executed in the main thread, the test thread, but after that, we got a background thread resolving, that's going to resolve using the mock. So we need to wait for that. So for that, we use the await entry point for the awaitility. We set up a timeout of 2 seconds. So if the test case takes more than 2 seconds to resolve the following condition, in this case, calling get state on the model, we can use a method reference, a lambda, if you want, and match with this particular Hamcrest match. If this condition is not met within the next 2 seconds, then the whole test case fails. You don't have to wait too much for that. You're also setting up an expectation. If it takes more than 2 seconds, then it's probably something is going on with the code. If the condition is met before the timeout, then the test continues, and now we can go with assertions. There are ways for you to configure the tick amount. I believe it's every 100 milliseconds as default, but you can change that, and there are other constraints that you can set on the wait method, and you can chain all these different conditions and timeouts and whatnot. There is support for awaitility for Java 8, as you saw, but it's also support for Groovy if you want to use clusters, or for Scala if you want to use Scala functions. And you can customize everything using Hamcrest matchers. Now, the final thing that I want to showcase before I tell you about that library is let me go back to the let's change to a different version of the application. And I was, for a moment, I was about to disconnect the network in order to showcase the test, but that would be very bad. So I'm not going to do that. But in the other way, let's say this. I know that our application can query the GitHub API and can query the real GitHub server. But it would be very bad for us to do that during testing because eventually we'll hit the rate limit. But it's also bad because we cannot assert what is the current state of the server at the other side. We could set up a fake server. We could set it up as part of the build. We can share it across different test cases, but we will still have the problem of setting the server at the right state for a particular test case. So it would be much better if we were able to embed a server in our test case and set the state right at the time that we need it and verify that the state was correct after the invocations happen. So what I'm going to do now is I'm going to run all test cases for this particular application. And one of these test cases is a functional test case that, that will hit a fake server. You will see that at some point in time, UI will appear and So that's the unit test happening, and the integration test will happen in just a moment. Yep, and the functional test will kick in right now. That's the. So that is actually querying a fake server that is embedded in the application, in the test case. And the test case should be green. There we go. Excellent. And let me show you the code of, I'm going to make it big in just a moment. So that's the functional test case. Let's make it bigger. And the project that we're looking at right now is called Warmock. So this being a regular JUnit test case, we can apply a JUnit rule that will create a fake HTTP server listening on this port, right? So the next thing we do is we configure our expectations. Let me make this a little bit bigger. Yeah. We configure our expectations, which is exactly what we have here. This block. So when this stop4 is a static method coming from Warmock, when that particular fake server gets a request, a get method that matches that URL, then we're going to reply with this particular value. So it's going to be a status 200, so everything is fine. We're going to reply text JSON. We're going to say that follow the next link with that particular URL. And this is a helper method that we got in the test case that will translate JSON Java objects into JSON, because that's exactly the body that we expect coming from the web server. And when we get another URL and another request that is of type GET, matching that particular URL, which is the URL that we set in right here, then we reply with another thing, and everything is peachy. By the way, this is test effects. This is the library that we use for testing Java effects. And I like to follow the same, even though this is not a Spark, this is JUnit, I like to use the given, when, then blocks so that we know what's going on here. Here's another way that we can set up another expectation. This expectation is when we cancel. And I believe there's expectation for failure. For example, even if we got the right URL, then we reply with a 500 error, and we expect the UI to handle it in some way. Let's go back to the slides. And that's exactly what we're telling you before, Warmock. It's a fake server that gets started for every method in this case. You can also use a crash rule, so the fake server will start for a whole test case, so you can share the state if you want to. And basically, it's a DSL for setting up HTTP response payloads. And they also supports record and playback features, because that's something that some people would like to have. And I believe this ends the current list of libraries. Also, let me remind you, everything again is open source. You can contribute to open source in a very, very easy way. The first step and the easy step is, if you find a problem, if you find something that is not going well, or something that does not match your expectations, you find a bug, please file an issue. The best thing that you can do is let the people at the other side of the wire know that you're using your project, but you encounter a problem. When you do this, please be sure to give enough information about the environment and the steps to reproduce the problem, so that it will make the conversation much faster, and perhaps the resolution of the issue much faster. If you have the time, and if you want to contribute source back, then please do so. You can contribute a test case, and if you want also, you can contribute a patch. But the best thing that you can do is file an issue whenever you encounter a problem. So the topics that I discussed today are covered in a newsletter. I have a newsletter where I send out information on these things, a few other. So if you are interested in following more and knowing more about these things, please subscribe. The other link is the same content, but in Spanish. If you know somebody that's a Spanish speaker and would like interested in the content, then please also let them know about these links. Again, you will have the slides, so this, you will have the links later. So for this, thank you very much. I hope that I was able to entice you to try out some of these libraries. And now I open the floor for some questions. So let's see. If you guys have any questions, let me know.
Do we have any questions? Yes, I'll try and relay it to you, Andrew.
Okay, yeah. Spock has sort of built-in conditionals for sort of delayed testing. One of the libraries you showed was just kind of exclusively about delayed testing, so is there a reason to use that library as opposed to the built-in Spock?
I assume you didn't hear any of that.
I heard something about Spock and conditions, but I couldn't get the main gist.
He's talking about Spock having built-in libraries for waiting on events, and I think in an example you showed another library. And is one you'd use one over the other?
Correct. There are two new features coming in Spock 1.1, which was released, I think, 1 or 2 months ago. The first one is that it has the capability to wait. Not so sure if, I think they were inspired by a utility, but I'm not so sure about the API. I haven't used it yet. And the other new feature that it has is the soft asserts. If somebody is aware of a project called JAssert or Google Truth, you know that you can bunch a series of asserts into one block so that you can verify all the asserts at the end of the test method. Instead of the first assertion failure, then all the other asserts will be skipped. Well, Spock gives you that capability. All right.
Spock can give you that capability to have the sub-assertion feature without having to rely on JAssert or Google Truth or other third-party library. This is, thank you for the reminder, because now I think that Spock has become kind of like the hub for most of the features that we like to have in testing. Yet, the only one that still doesn't have is dependency injection. Maybe in the next release.
Cool, thank you. Any other questions? No, I think we're probably all quite overloaded. There's a lot of different frameworks, a lot of interesting things. So I think, well, thank you very much for your time. Obviously, letting us kind of, I suppose it's a bit of an experiment for us in a sense to kind of try out this remote connection, but I think it's gone fairly well. It's a new experience, and obviously we'll probably learn a lot from it. Hope to do it again sometime. Yeah, thank you.
Thank you very much for participating in this experiment. I'm hoping that you guys like it, that the delivery and everything works pretty well with network. I was a bit scared, but looks like everything went well. So hopefully this won't be the last. It will be the first of many other opportunities for the Manchester Java community to get access to different content.
Brilliant. Yeah, thank you very much.
Well, so thanks again. If you have any comments or any follow-ups, well, just get in touch with me. I guess I put it here on the slides, but I'm not sharing the slides, of course. So I'm going to share them again. Start a screenshot. So here are the slides. And you can reach me on Twitter. You can search much information about that. So please let me know. If you like it, let me know. If you didn't like it, I would also like to know. So that's how I can make it better. And any other things, well, just I'm there. I'm on the network. I'm available.
Yeah, and I think we've recorded the event as well, so we'll share this video with everybody, so you can kind of watch it back. We usually ask our speaker to do the raffle draw for us, but that'll be a bit difficult tonight, so we'll probably skip on. But yeah, thanks very much. I'll try and hang it all up now. Thank you.
Thank you, everybody. Have a nice evening.
Cheers.